Hey, this is Mr. Ward, and this is a video key for Do Now 13.2 for Wednesday, the 9th of December. So who are you? Well, I am the key. So here we go. What is the probability of drawing a king of any suit from a deck of 52 cards? So there's 4 kings in a standard deck, and yes, we're talking about a standard deck, no jokers, no shenanigans. So the probability of a king of any suit, okay, is going to equal, so there's 4 desired possibilities out of 52 total possibilities, so we can simplify 50 seconds into 1/13th, and that's the probability. And if you want to turn that into a decimal or percent, you can, but I'm generally going to put it in a fraction form most of the time. So now what's the probability of not drawing a king? So that's the probability, and this is called a complement, okay, probability. So I'm going to put a little tilde symbol, and I'm going to write king. So that means not drawing a king, okay, of any suit. Okay. And I could just leave out of any suit. I could just say king because I'm just not specifying a suit, so you can assume I'm not caring about the suit. So the probability of not drawing a king is going to be 1 minus 4/52, which will be 1 minus 1 out of 13, which will simply be 12 out of 13. So there's 12 possibilities out of 13, or 48 possibilities out of 52 in order to get a no, not a king. So by the way, that 1 becomes a 13/13, so we can do the subtraction and get that 12 out of 13, and that's where that comes from. Okay, what's the probability of drawing a king of any suit and then a 2 of any suit without replacing the cards? So what you're going to need to do, so this is the probability of a king, then a 2, no replacement. Okay, I'm just going to write NR, which I don't think is the formal language, but hopefully you understand that that's NR for no replacement. And so it's going to equal our original probability, which we calculated as 4/50 seconds, or 1/13th. Okay, 1/13th. And then the chances of drawing a 2 now are 4 out of the remaining 51 cards, because we didn't put any back out of 51. Okay, so our numerator will be 4 because there's nothing I can cancel out. And our denominator is going to be some fairly large number, so you might very quickly be able to rule everything out except for this one. Well, let's calculate it out. 51 times 13, so 1 times 13 is going to be 13. And 5 times 13, oh, that's really 50 times 13, is going to be 650. And we put it all together, and you end up with 663, which definitely doesn't share a factor with 4. So there we have it, 4 out of 663. I will remind everyone that I'll remind you all about this in a second. So what's a sneaky way to do this calculation? We got 31 factorial over 29 factorial. Well, 31 factorial equals 31 times 30 times 29 factorial. So when you do that, we can say 31 factorial over 29 factorial equals 31 times 30 over times 29 factorial over 29 factorial. And so the 29 factorial goes bye-bye, and you're left with 31 times 30. I'm sorry, times 20. What am I thinking? My goodness, brain. I hope you noticed. Yeah, no, that's right. 31 times 30. Okay, yeah, 31 times 30. So 31 times 30. And so 31 times 30 is going to be 930. I tricked myself for a second there. Okay, so that's the answer. Just all you have to deal with is those first 2 factors of the 31 factorial, because everything from 29 down to 1 went bye-bye. I'll just remind you, grades closed on Friday. I can still accept any probability level stuff up until today, which is Wednesday. So if you do have any of that stuff to turn in, please get it handled. And various other things in here. I'm going to stop the video.